Hello, I'm James Ingram for AutoControls.org. This video 825 is sort of a follow-on from the previous video 823. In that video 823, we used a pair of push buttons to allow the public to operate a train running point to point. In this video 825, we use those same two push buttons to allow the public to run a train forward and backwards on a circle of track, as you see behind me. We don't need the detectors for this manual operation unless we would want to restrict their operation to just part of the circle. And we also have an automatic sequence using a single push button where they can push the button once and it'll start a sequence where the train will go 2 laps or 3 laps or 4 laps around the layout and then come back to the station and park. You'd want to give them either one or the other, the 2-button system or a single button system, not both at the same time. That would be confusing. And we'll show this, but the controller here has 1 button as it's sitting here now, and then 2 buttons is on the bottom, and I just flip it over. And the NCE Mini Panel is a $49 off-the-shelf, simple programmable controller for model trains. And note this Railking logo you see behind me, the green logo. That has had the DCC switch added to it, plus it's had the rooftop strobe light added to it. Normally Railking engines don't have a DCC switch unless you get one that was made between 2011 and 2014. All the Premier engines do have the DCC switch, however, but this is a Railking engine back here, so we had to add that switch. And one more thing, I'm using an NCE power cab. NCE says not to use the power cab on O gauge because it's not big enough. But don't let that confuse you, because all the NCE systems have the same commands and they behave the same way. In my case, I'm running a small loco with only a couple of cars at very slow speed, so I can get away with it. NCE is concerned probably somebody's going to take an MTH big boy and hook it up to 20 cars and try to pull it, and of course that'll completely fail. My power cab only puts out 1.3 amps at 13 volts. It's an older one. The newer ones put out 1.8 amps at 13 volts. Thanks for watching. This is a demonstration of what we call Mode 1, where we offer 2 buttons to the public, a forward button and a reverse button, and we have a sign that says hold a button to run train in either direction. This is the same thing as we were doing in previous video 823, except video 823 was on a point-to-point system, and this is a circle of track. And notice down there on the right, at the far end of the straight section, that we have the Z-stuff detector as before, a single detector, but we don't need that for this mode 1 of operation. It'll be used for mode 2 where we're running automatically, but we don't need it for this mode 1, but it's just there as kind of an attraction. And so let's power this locomotive up, or I should say turn the sound on, and we can demonstrate. Now if we push the forward button, the loco will go as long as the button is pushed. It'll stop when the button is released. So again, this is something we could really offer the public on a public display. And whenever that button is released, the locomotive will stop. And likewise, the same thing happens in reverse. Again, if we release the button, the train stops. If we push down on the button, the train will start up again in reverse. And this is set up so it runs speed 6 in the forward direction and speed 4 in the reverse direction. So right now it's running at speed 4. If I push the forward button and hold it down, when it starts up in forward, you can see it's running a little bit faster because it's running speed 6 versus speed 4. Now, if somebody happens to push down both buttons simultaneously, it'll run in the forward direction because it's set up to look at the forward button first, so it'll just ignore the reverse button if both of them are held down. Now we'll demonstrate what we call Mode 2 operation on this system, and that's where we use a single button instead of 2 push buttons. Recall in Mode 1 here on our control panel, we had 2 buttons that the public could run the train forward or reverse by holding one of those 2 buttons down. Now I flipped this control panel over, and now we've got the single button, and the sign now says push and released will make one start, run, stop sequence. And so again, this is designed so that you can put this button someplace if you had a display you wanted the public to be able to operate it. And you can see we've got the Z-Stuff detector down at the far right end of the straight section. That's a DZ1012 detector, which will sense when the train goes by. And you don't have to have a detector to do this automatic operation, but using the detector we can park the train pretty close to the station. This is set up so the train will make 3 laps from where it is and come in and park pretty close to where it's sitting now, because the detector will allow us to sense where the train is, and using time delays we can run it up pretty close to the station. So I'll go ahead and turn the loco on to get the sound. Now we'll push this button here that says start. Now this is set up so it rings a bell for about 8 seconds at speed step 2, and then it speeds up to what I call a cruising speed of speed step 6. Now it'll make about 3 laps before it comes back to the station. That was the first lap. Now the second lap, you should hear the horn. There's the horn. That means we ended the delay statement that allowed us to cruise, and the detector sensed the train. Now the second time around we'll see that we'll hear the horn again. That means the detector sensed the front of the train. It's using a time delay. Now there it reduced the speed down to speed step 2 again, and it's ringing the bell. And you can see it pulled it up pretty close to the station. Now that train will sit there and wait, be it a minute or an hour or whatever. You'll have the front light, the front headlight, the rear light, and the sound, plus the overhead flashing beacon on top of the cab. You'll have all those effects going, but the engine won't be putting anywhere on the drivetrain. Say this is on a display and nobody's watching it. It'll sit there and wait till somebody comes along and pushes the button again. So let's do that. We can push the button again, and it'll initiate that same sequence again. And we can adjust the length of the delay statement to make this thing go more laps around. You can't really count laps with this mini panel we're using as a controller. It doesn't have that capability, but we can put delay statements in to get approximately the number of laps we want. Now there's our second lap. The first time around it just senses the train. It may pick it up at the engine, or it may pick it up at the end of the train or the middle. We don't know exactly where. That's why we sense it twice. Now there it sensed the beginning of the engine, so we can accurately start counting time. There again, it pulled into the station and waited. You can modify this sequence how you like. You don't have to have it ring the bell or run at speed step 2 like we're doing here. You can, set this thing up any way you want to. That's kind of the fun of it, getting the sequence you like the best. Now let's push the button a third time. We'll just do one more iteration of the same sequence. And notice we only need one detector to do this operation. We used this button controller here for previous video 823, but that was point to point, and we had 2 detectors. Here we only need 1 detector. We could use 2 detectors if we wanted to restrict this thing to running just to a certain part of the layout on the back and forth, but otherwise 1 detector works fine. And like I said, you could use no detectors to have the train run the same sequence. You just wouldn't be able to accurately park it in front of the station like we're doing. Now that's the third time we did that with this button, and again the train will just sit there and wait however long it takes till somebody comes along and pushes the button again to start it up again. And there it goes again. Now if we position the camera a little bit, and we'll demonstrate mode 3, what we call mode 3. It's almost the same as mode 2, but instead of a member of the public pushing this button on the control panel, the operator can close a switch on the operator's control panel, which is over here. When we close this switch, it's hooked to the same input 1 as the button is, but when we close that switch, it'll keep input 1 grounded, which will cause the train to make that sequence continuously. So the train will do the same thing it just did a minute ago, but it'll be repeating that routine as long as that switch is kept closed. So let's do a demo of that now, and again we'll turn the sound on. And I'll go close that switch. And close that switch that I just closed and this button here, they're both wired in parallel to input 1. So you could have actually more than 1 switch and more than 1 of these buttons. And if any one of them is closed, after that train completes its sequence, when it checks, the controller checks if input 1 is closed, and if it's closed, it'll repeat the sequence. Now that's the second lap because the horn blew on the second lap. Now there's the third lap, and it should start approaching the station again. Now this is the same thing that happened a minute ago when we pushed the button, except that we have a time delay to sit at the station, and because that switch is closed, it'll start repeating that sequence automatically. Now we're completing our first lap around the loop. Here's our second lap. Same thing, the horn should blow. There's our second lap past the station. There's our third lap. Now if I go over and open that switch, well, let's let it run. Let's let it run a third sequence around it. This is the second sequence. It's set up to wait about 7 seconds at the station, and when it's done with that 7-second wait, it'll check if input 1 is closed. And again, because that switch is closed over there, it starts that sequence again. I'm going to go over and open that switch. I just opened that switch. So it'll complete the sequence again. But when it makes that 7-second stop at the station, it'll check to see if input 1 is closed. And since the switch is open and nobody's pushing on the button, input 1 will be perceived as open, and it'll just stop and wait. Now there it comes into the station again. Now it'll wait 7 seconds, make that check to see if the switch is closed or if the button is pushed. In this case, neither is happening, so again, it's just going to sit there and wait until either somebody pushes the button again or closes a switch, and then it'll start repeating that sequence. Here, I can push the button. Take a quick look at the system here. Here's our power cab, which we've been using to control this system. And again, I repeat, NCE emphatically says you shouldn't be using the power cab for O scale. I've just been doing it because it's convenient to use it, and I like the fact that I can see how many amps the system is pulling, and plus it's kind of compact. But again, according to NCE, you should be using a regular Power Pro station, because these O-gauge engines, like, they can pull well over 3 amps, and my power cab is actually limited to 1.3 amps, so I can get away with it for running on these little displays where I'm running a small engine at a very low speed with just a couple cars. And over here's our what I call the control panel. Here's what we call the mini panel. This is what actually is doing the controlling, and this, again, this is a $49 off-the-shelf component you can get from NCE, and this is the power control panel, which is what hooks the power cab up to get the power coming out. You wouldn't need this if you were using a regular Power Pro NCE system. This is the reset button. We don't need this for normal operation, but if we're testing it, sometimes we need the reset button. This is the switch here that allows me to close this switch and keep it running continuously. And then here's your inputs coming in off the layout. This is a detector. This yellow wire here is where our detector hooks into the mini panel, and these wires are where our 3 buttons connect to the mini panel. And this is our MTH connector that puts the power into the track. And then down here we have the DZ 1012 detector. And again, when either a train or my hand interrupts the infrared beam coming out of there, you can see it shifts from green to red. And there's a DZ 10008 relay hooked up to that detector. And when this thing goes to red, it closes the points and goes on these wires back here to the mini panel, and it can sense that those 2 wires are connected, and it basically just connects the input 14 to the ground, and that's how it senses the train is going past. Now, this is the unit we're using for this circle control. Here's the unit we were using in the previous videos for the point-to-point operation. Of course, we could have just reprogrammed this, but since these things are relatively not too expensive, about $49, I find it easier just to have several of them. That way I can keep my point-to-point programming in this one and use this one for the circle operation. They only have about 30 input locations, so you got about 120 commands you can write. It's limited, hence the name Mini Panel, so you can only put so much programming in one of them. And one more comment about these Z-Stuff infrared detectors. I've hooked up the DZ1011 detector in the rear behind the DZ1012, which is in the front. And the DZ1011, the rear one, is actually the cheaper one to use. The one advantage of the more expensive DZ1012 is that the light's a little more visible. And you can probably maybe see that as I start going away on an angle from these. The one in the front is a little more visible than the one in the rear. And likewise, if we go up on a different angle, but both will do the job of detecting the train. The DZ1012, the front one, the more expensive one, has an adjustable time delay, which we don't need for this application, so you could say it's overkill. But in either case, the nice thing about these Z-Stuff detectors is there's no connection to the track. I can actually take this away from the track, or relocate it to a different part of the track. There's no hooking up anything to the power rails or cutting blocks in the track for detection or anything like that. So it makes your hookup nice and simple and flexible. You can take it away if you don't need it or whatever. So this loop of track you've been seeing in the video, there's no blocks or anything like that. The only connections to the track are what you see here, just the two wires going into it for input power. There's a delay statement in the routine that this mini panel controller is executing that controls how many laps the train goes around the loop. I've reduced that time so that instead of making 3 laps around the loop, the train will make just 2 laps, and we'll demonstrate that now. Now we should hear the horn the first time around. Now that's our first blowing of the horn. And there's our first lap past the station. Now when we get to the detector again, we should hear the horn again. Now it starts executing a time delay to get past that detector and reduce the speed to creeping speed 2. And it's executing another delay statement to bring the train up to the station. And let's take a look at that again. This time I closed a switch that's over there on the control board. Remember that switch is wired in parallel with this button, so either one of those will start the train. There's the first lap around the station. There's the second blowing of the horn. The second lap. And as before, we're creeping up toward the station at speed step 2. We'll stop. Now, because the switch is closed, that'll sit there for about 7 seconds. It'll check that the switch is closed, and it'll repeat the routine again. There's our first lap past the station. There's our second lap. Pulling into the station as before, and this will just keep repeating that 2-lap sequence for as long as that switch is closed or anytime the button is pushed.
Have the inspector check that out.
Now I've increased that delay statement to a bigger number than before, so we should get 4 laps this time around. The delay statement basically tells the controller to do nothing. Now there's the first time past the detector. And here comes the first lap around the station. The delay statement tells the controller to do nothing. So the longer the delay statement you put in for travel time, the more loops that's going to make. If you put like 10 minutes in, it would make a lot of loops around. Now here's the second lap past the station. Now we're starting our third lap, and this time the delay statement should have ended, and the controller will be looking for the detector to be crossed, and they'll blow the horn. So there's our third lap past the station. And there's the second blowing of the horn, and this is our fourth lap that will approach the station. And it'll just keep repeating that 4-loop sequence. We'll do it one more time. There's the first time past the detector. And here's the first lap past the station. There's the second lap past the detector, second time past the detector. And here's the second lap around the circle past the station. Now here's our third time past the detector. We should get the horn. And there's our third lap past the station. There's a second horn blowing. And the end of our fourth lap as we approach the station. So we can put in delay statements of varying length. As you recall, we started out with 3 laps for the first demo, then we reduced it to 2 laps, and then we changed it up to 4 laps, so you can get various numbers of laps around the circle. And like I said, we can't count times around the circle, but we can basically trial and error, increase or decrease the delay time to get different numbers of laps around the circle. I know I timed it. It takes about 17 seconds for this train to travel around this loop, so I know if I increase the delay time by about 17 seconds, I'll get an additional loop. Here's the drawings for this setup, and you can find them on the web at AutoControls.wordpress.com, which is part of the AutoControls.org website. Here's the overall wiring diagram, and it's almost the same as what was used in video 823, except we only have one detector for this system. as mentioned in 823 was point to point, and we needed a detector at each end. For this one, we need no detector at all to use the forward and back push buttons if we're letting the public operate the thing. We need one detector if we're counting laps. We're actually not counting laps, but we're controlling laps with a delay statement. We do need one detector for that. And then as far as the actual detector drawings, this is the drawing for the DZ1011 detector, which is the most economical one to use. And then over here is the drawing for the DZ1012 detector, which is a more expensive detector, but the advantage is the lights are a little more visible from different angles. Before we look at the routine we're using in this O-gauge video, let's look at a simpler version. What we're seeing here is from video 816, part 4 of 5. That's the beginner exercises for the NCE Mini Panel automatic train control. And this is what we're seeing as the commands for demo 10 in that video. And again, let me repeat, this is not the video you're watching now, the O-gauge video. This is an earlier video. We controlled a Kato HO gauge loco, but this was the simplest way to write those commands, just a simple stopping routine. And this should make sense to you even if you're not familiar with DCC and you're not familiar with the mini panel, because it's plain English. But the first thing we do over here is we select our loco, which happened to be 3364. That was the HO loco. We said speed forward 16. That told it to start up at a speed of 16. Then we delayed a quarter second times 40, which works out to 10 seconds, and that's the amount of time the train will run for. And then after that delay ends, we say speed forward 0. That stops the loco. Now we have a second delay. We say a delay a quarter second times 24. That delays for 6 seconds. That's how long the loco was parked. Then within our next command is link to input 7, and that takes it via, you can see via the purple arrow, that takes it back up to the start of the routine, and it repeats all over again. So this little routine, as you may have seen it in earlier video 816 with the HO loco, just started the loco up, ran it for 10 seconds, stopped it and parked it for 6 seconds, then repeated. And notice there's no way to even gracefully stop this routine. We had as the note says up here, we have to use the reset button while the loco is stopped to stop execution. That's what the reset button does. It basically forces the mini panel to stop executing. Here we're looking at the part of the command file used for demonstrations 2 and 3, which is where we push the push button or we close that switch to start the automatic sequence. And the push button and the switch are both wired to input 1, which is shown here. So if somebody pushes that button or closes that switch, it's detected on input 1, and the commands we see, it selects the loco 779, that's the green one, gives a command to turn the headlights on, then it links the input 8, which is further down, which is where the main part of the routine is. And this is typically how we use this mini panel. We disable, in this case I've disabled inputs 4 and above, so we're just using inputs 1, 2, and 3 for buttons. In the mini panel it'll check inputs 1, 2, 3 if it's not busy doing something. So if it's in the idle state, it'll look for one of those 3 buttons to be pushed. And here's buttons 2 and 3, which are the manual operation, and we'll look at that routine later. But like I say, this is the routine for the single push button we're looking at here. And down here, these are test programs. down here. In this one for testing the buttons and detector, we demonstrated that in video 823, section 13. Now here's the commands that we use for demo 2 in this video, where we push a button and the train makes a certain number of laps around the loop automatically. And we've actually got 7 delay statements. And let's look down here at the bottom of this little sketch. We see the station and the locomotive sitting next to the station. So when we push the button, the first delay statement we have is we start the train up with a speed of 2, and we ring the bell. And the first delay statement controls how long that process happens. I think it was about 8 seconds, as you saw it in the video. And when that delay statement ends, we speed the train up to speed, I believe it's 6, which is I call it the cruising speed. Then we have delay 2 takes effect, and that controls how many laps the train takes around the loop. If we make that really big, like 5 minutes, it's going to make a whole bunch of laps before anything else happens. You can think of the delay statement essentially as telling the controller to do nothing or go to sleep or whatever. It just doesn't do anything. At any rate, when that delay 2 ends, then we start looking for the detector, and you can see maybe the engine over here shown lightly as it's approaching the detector. When we cross that detector after delay 2 times out, we blow the horn, and delay 3 controls how long we blow the horn. That's 1 second. And then we have a delay 4 to get the train past the detector. And then we want to start looking for the detector a second time, so the train will come around again and it'll blow the horn the second time, and that's delay 5 controls that, and that's 1 second again. Then we have delay 6, which brings the train up here toward the station, and at this point we reduce the speed to 2 and we start ringing the bell, and then delay 7 is in effect. That controls how long that train creeps at speed 2 while it's ringing the bell to get it up to the station. And when that delay ends, we stop, and there's actually a delay 8 that I don't have shown here, but that control right here, that shows how long it waits at the station, and we start over again. So let's go look at the actual command brief. It'll go up here in the upper left corner where it begins. This command turns the bell on. This is when we're leaving the station. Speed step 2 starts us creeping out of the station. This first delay, 8 seconds, is how long we creep out of the station with the bell ringing. And then we give a command to turn the bell off. That's what this is. Now we increase the speed to 6, which is, I call this the cruising speed. And then we have another delay. This is our delay 2, which controls how many laps we make. This is set for 20 seconds, as you saw it in demo 2, and that causes 2 laps around the loop before it comes alive and starts looking for the detector again. I'm calling this travel time. And I made additional notes. It takes about 17 seconds per lap for that train to get around. If we set that to just a quarter seconds, then that results in 2 laps, which I think was demo 3, I believe. And then if we set it to 116, which means it's 29 seconds, that causes 4 laps. So what this is just me making some notes of what different delays result in how many laps for the little loop of track you see in the video. At any rate, we have our second delay in process, which controls how many times the train travels around the loop. When that ends, the detector comes to life again, so to speak. And we have this wait until input 14 is ground statement. That basically waits until the train crosses in front of the Z-stuff detector, and the Z-stuff relays contacts close, which signals the mini panel controller that the train is there. Then we turn our horn on, blow it for one second. That's delay 3 is set to 1 second. Then we turn the horn off. Then you have this delay 4 of 7 seconds, and that's just enough to make sure the train gets past the detector before we start looking for it again. If we didn't have this delay, the one of the cars could still be in front of the detector and it would immediately blow the horn the second time. We don't want that to happen. So this delay 7 allows us enough time to make sure we're past the detector. The train will make another loop, and again we'll look for input 14 to go to ground, which is a Z-stop detector closing its relays. And as I put a note here, waiting for the detector a second time ensures we begin the station approach sequence from the front of the loco, not the middle of the train. So we turn the horn on again, ring it for, blow it for 1 second, turn the horn off, and then we start a 4-second delay. 16 times a quarter is 4. We start a delay 6, which takes us beyond the detector for 4 seconds. Then we decrease our speed to 2, turn the bell on. We delay another 8 seconds while we're creeping toward the station with the bell on. Then we set the speed to 0, which stops the train. Then we turn the bell off. So we basically adjust these different delay times to get the train up to the station and have the bell ringing for whatever amount of time we want it to ring. And finally, we got this delay 8, which is how long our train sits at the station. That's set for 7 seconds. Then we have a test as to whether that switch is closed or not. This is the same as previous videos. It says skip if input 1 is ground. That means that the switch is closed on the operator's control panel. Input 1 will be grounded, so it'll skip over this terminate statement, go to this link to input 8 statement, and that takes it back to the top, up here to upper left where it starts all over again. Now, if the switch is open, meaning the operator wants to stop the train, or if we were just using the push button, then this skip if input 1 is ground statement is false, so it won't skip, and it'll execute the terminate statement, which will stop the process. So the train will stop running. It'll just sit there idling with the sound on, the lights on, and the cab roof light blinking. It'll wait for either somebody to come along and push the button again, or the operator to close switch number 1 again. If we look at the flow chart for the previous video, 823, this was where, if you recall, where we had a point-to-point operation with a detector at each end and 2 push buttons, a reverse push button and a forward push button, so we could allow the public to operate the train, but we had to have logic to keep them from running the train off the end. So we built that into the control sequence, and we had basically a logic, a test, I should say, here. Is the reverse detector clear, and is the forward detector clear? And if those detectors were blocked, which means the train was at one end of the track, we had to have logic to basically stop the train. In other words, if the detector was blocked, we set the speed to 0, and then we went back and rechecked everything. Now, what we're doing here, and remember, this is the old video, 823. Now, what we're going to do here with our current video, we have similar logic, but it's a little simpler because we don't have to worry about the detector. So if you remove these statements here involving the detectors and whether the detectors are clear or not, we get a similar flow chart, but it's simpler because all we have to do is worry about is the forward button pushed or is a reverse button pushed. So what happens here, if somebody holds down one of these 2 buttons, it comes in here, or then there's a delay statement just to keep it from trying to repeat repeat the loop infinitely, but it tests to see if the forward button is pushed. If it is, sets the speed to forward to 6, and then goes back and rechecks. And likewise, if the reverse button is pushed, when it comes in here, this will be a no, but it'll go check if the reverse button is pushed, and if it is, it'll set the speed to reverse 4. Remember, we ran forward speed 6 and reverse speed 4, but we could have these any speeds we want for these, but this is the logic of how we handle it. And then if the people release the buttons, both buttons are released, it'll come in and test for the forward button, no, test for the reverse button, no, so it'll set the speed to 0 and end the routine, and the loco will just sit there on the track and with the lights on and the sound and the rooftop strobe flashing, but it won't be going anyplace until somebody comes back and pushes the buttons again. And as before, these numbers here translate to what statements in the command file actually cause this process to happen. So now that we've looked at the logic, let's go take a look at the command file for a minute. Here's the commands for that flowchart we were just looking at, where we, and this is for demonstration 1, where we had the public able to push either the reverse button or the forward button to manually operate the train. And this is basically the same commands as we had in video 823 when we had 2 detectors at the ends to worry about, except I just went and removed those commands, and you see these no-op statements, which is a no operation, do nothing, just go to the next step. I put these in where we had a command for the detectors. Notice there's still a detector shown down here at the bottom because there is a detector in this video, but it's for the demonstration 2, where we're using the single push button and keeping track of laps. It's not, the detector's not used for this demonstration 1 with the 2 push buttons, so we wouldn't even need the detector to do this operation. Note there's no commands in here to check the detectors. At any rate, starting at the front of the file, we have our delay statement just to keep our processor from trying to loop at infinite speed. Then we check if input 3 is open. That's the forward button, and if that's pushed, we go to input 17, which is down here, process the forward button, and it sets the speed forward to 6, and it links to input 15, which is back to the top of the thing, and starts checking again. Now, if the forward button's not pushed, then we check if the reverse button's pushed, and if that is pushed, we get down to input 18, and it says process reverse button, and we set the speed to speed reverse 4, and then we go back to, it says link to input 15, so we go back to the top and check again. Now, if whoever's operating this has released both buttons, and it comes in to check the forward button, and it won't, it'll skip this statement because no button, the forward button is not pushed. It'll come down here. It'll skip this statement because the reverse button's open, that is to say not pushed. It'll set the speed forward 0, which will stop the loco, then it'll end the process, and again the loco will sit there and wait until somebody comes in and pushes one of the buttons. And if they push both buttons down, which I demonstrated, it'll still go forward, because when it comes in, the first thing it'll check for is if the forward button is pushed. If it is, it'll go down here and set the speed to 6 forward. Now here's that same setup we've been using this whole video, but now we've got 2 trains on the track. I'm going to go over there and throw that switch on the operator's panel, and that'll start up this operation. When that yellow engine crosses in front of the Z-Stuff detector, the green one will be started up, and the yellow one will be parked in front of the station in the corner. That'll wait until the green engine crosses in front of the detector, and the controller, that is the mini panel, will start the yellow engine up. Then it'll run the green engine up and park it in front of the station. And that process will keep repeating as long as that switch number 1 is closed. You can see it has to pull the train far enough past the detector and park it so that when the next train comes in, the train that's stopped will have time enough to get started up and get out of the way. Now if I open this switch, I just opened that switch number 1. You can see the system stopped itself just like it did before, and it'll wait till either switch number 1 is pushed or button number 1 is pushed. I'm going to push button number 1. That'll start it up. So we'll cover this in more detail in the next video.